starting with exponentials, I'm actually going to blend in a lot of the exponentials and its equivalent logarithm lesson. Looking at the graphs, is this an exponential graph or a logarithmic graph? It's exponential. And I'm going to remind you why. There's three things that are very important for every exponential. This is an exponential function. How do I know it's exponential? The easiest way to tell is it's right here. The easiest way to tell if it's exponential or logarithmic is to check out the asymptote. If it's exponential, it's horizontal. If it's logarithmic, the asymptote is vertical. What's my asymptote this time? Do I have a horizontal asymptote or do I have a vertical asymptote that the graph's approaching?
Horizontal.
Horizontal. Add that. Oh, you don't have a packet. Sorry, what am I saying? If you're doing a quick sketch, if you do a quick sketch, just so you know what you're looking for, very quick sketch, make sure, more important than the points, is to put that it has a horizontal asymptote there. So if you just want to draw the curve up with the horizontal axis, horizontal asymptote, I should say, it's an exponential function. We know it's an exponential function because it has a horizontal asymptote. That's the key that gives it away more than anything else. What's the equation of this asymptote? Would it be an x equals or y equals, do you think?
X equals.
A lot of people think x equals because it models the x-axis, but it's not. Because the x's are always changing. For example, right here, the x is -5. Over here, though, the x is +5. The x is changing, but you know what's not ever changing? The y's. What are y's at both points? What's the y value both here and there? 0. It's the x is -5, then the x was +5, but the y never changes. The y was always 0. Other key points that you should know is an exponential function without a transformation goes to the point 0, 1. And then after that, each point is n, comma, bn, where n is an integer. Actually, n doesn't have to be an integer. It can be any real number, but we just use integers. N can be any real number, but that's how you can find any point on it without a transformation. Those are without transformations. We go with that. Those are the three things of exponential. That is if there's no transformation. So this one does have a transformation, but typically they go to that point because if you plug in a 0 for n, what is any base, no matter what the base is, raised to the 0 power? 1. And so you'll end up with that point if there's not transformations. Now this one has one, because you see how we don't go through that. This one, it looks like it's been, the a value would be 3, it's been multiplied by 3. That's why it's not 0, 1, it's 0, 3. But that's where you get that. Okay? Do you have down, that part's the important part. Oh, it says limits. We'll get there here, and it's at the end of the lesson. Let's go talk about this limit right here. This limit. I'm going to call this f of x, this equation. What happens as we go left? As we go left, does this exponential fall forever? Does it rise forever, or does it appear to be getting flat and following an asymptote? Flat. What's the y value of that asymptote? 0. That would be that limit. And what about the limit on this end of the graph? What happens as we go to the right forever? Does this graph appear to rise forever? Does it fall forever? Or does it get flat following an asymptote?
Rise.
Rises. What you're going to learn is that every exponential function has a domain all reals, meaning x will go from -infinity to +infinity. Not what you're going to learn. Hopefully I remind you what you've seen. Every exponential, the x's go from -infinity to +infinity because the domain's all reals. But the y's will go from a constant to an infinity, whether positive or negative, depends on the problem. But you'll have one that's a constant number, one that's an infinity, positive or negative, for every exponential. One that's a constant, one that's an infinity. Okay? I got three more examples of this. So I don't want to spend too much time on this one slide. Let's go to the next one. This time, what do you think? Exponential or logarithmic? This one's logarithmic. So this one's technically less than 2.9. So the last one was less than 2, 3. This one's less than 2, 9. So when we started exponential logarithms, how do we know it's a logarithm? What do we call this? A vertical asymptote. So let's make basically the same statements. Logarithmic function has 3 key features. So this is an inverse. So everything should be kind of like the opposite. Instead of a horizontal asymptote, what does it have instead? Vertical asymptote. That's key feature number 1. On this one, what is the vertical asymptote located at?
2.
That point right there is 2. I know it's tricky here, but it's 1 box over. So we'd actually say it's at
1.
1. Now, what is it 1? Is that the x value of 1 or a y value of 1?
X.
That's an x value of 1. So this is x equals 1, that equation. So this has a vertical asymptote at x equals 1. Typically it's at 0. This has a transformation. Every logarithmic function has a vertical asymptote. Typically, without a transformation, it goes to the point not 0, 1. But what would it go through instead since it's an inverse?
1, 0.
1, 0. Typically, it goes through 1, 0 without a transformation. This one doesn't go through 1, 0, it goes through 2, 0 because which way has it been shifted? It's been shifted 1 unit to the right. Okay, also, instead of going through the point n comma base raised to the power n, what does it go through instead? There you go, you just do the inverse. Every point can be found doing base to the power of n, comma, n. Again, where n's an all real number, where n is a real number. Typically, we just plug in whole numbers, but. Second to right. Question for you. On the last slide, I said every exponential, on the limits, one will be negative infinity, one will be positive infinity. Will that be true for a logarithm? No. Now that will be the y's. One will be positive infinity, one will be negative infinity. So if I go to these limits, this limit here, what's happening to the graph on this side? I'm going to call this one, well, I'll just call it f of x again. What happens on this limit? Is this rising, falling, or getting flat?
Right.
I'm sorry, flat meaning horizontal. It's rising. So infinity. Where's the x going? It's actually not going to infinity. X is getting cut off somewhere. Where's it getting cut off? At 1. Now, it's 1 plus because we don't actually get to 1. Remember, limit doesn't tell you where the graph is. It tells you where it's going. We don't get there, but we're coming from the right side. Okay, and then this limit down here. This time, what's happening to the y values? Rising, falling, getting flat. Falling. So this is a negative infinity. So now the range is all reals. But the x is to go to positive infinity. So the inverse is true here. 1x value on a logarithm and a limit, 1x value will be a constant, the other will be an infinity. Whether positive or negative depends on the transformations. 1 constant, 1 infinity, the y's will be from negative to positive, one way or the other. That's always true, always, always, always. Unless you're cutting off the graph and only looking in a certain interval, without a restriction, that would be always true. The y's, yep. It'll rise, it'll be all reals in the range. One end's rising, one end's falling. Whereas exponentials, what's different? Is it's talking about the domain. One will go left, one will go right on exponentials. Okay, I got 2 more. Let's go a little quicker. What would you say this one is? How'd you say, how'd you find out exponential so quick? What'd you look at? A horizontal asymptote. So this one, we're just gonna say exponential. I'm not gonna write all the extra stuff. I'm just gonna say this is exponential function. I'll just say exponential this time. If you're gonna do limits, this limit here. It kind of looks logarithmic, doesn't it? But if you look at your asymptotes, you can tell it's exponential because it's a horizontal asymptote. What's y doing? Is it rising, falling, or getting really flat? It's flat. So this is the constant. What's the constant number it's approaching? 2. You do not have to do a minus or a plus or anything like that on the y's. What about x? Which way is x going? Infinity, going to the right. Okay, and then what about this other limit over here? What's happening to the y's? They are falling. And what's happening to the x's? They're going left. So, like I said, every exponential, the domain is all reals, so your limits will be from negative infinity to positive infinity. But the range is not all real, so it'll always be an uninfinity until and a constant.
So exponentials have horizontal.
Always. Yes.
And the other for logarithms is
Vertical. Yep.
always.
Always. So horizontal asymptote will be the number on the one limit that's a constant, whatever that is. No matter if you're talking about exponentials or logarithms, whatever your asymptote is, in this case it's y equals 2. That's going to be the constant that fills in the limit.
The x is where the limits, they will go with the d.
Yes, for exponentials, because they're all reals. Exponentials are all reals on domain. Logarithms, the range is all reals. So that's why on exponentials, the limits are a negative infinity and a positive infinity, because that's the all real domain. On logarithms, it's the range, the y's, the f of x, that'll be negative infinity to positive infinity, because that's all reals. Okay, I got one more to make sure you got this down. One more. Don't call it out this time. Let everybody look at it for, give you at least 6 seconds. All right. What do you think? Exponential logarithms. 5, 4, 3, 2, 1.
Logarithm.
Why is it a logarithm? You saw vertical asymptote. It's the easiest giveaway. It's the asymptote. This has a vertical asymptote. Therefore, it is a logarithm. Where is that asymptote located? Because this would be our constant for the limit. It's at -5. And is that a y value or an x value that's cutting through there? X. This is x equals -5. So that will be the one constant value. So your limits, the only limits you should expect to see on a test over exponentials or logarithms, will only have infinities, negative infinities, except for one constant. That one constant is going to be the asymptote -5. Let's plug it in. Tell me about this limit over here. X. Is it rising, falling, or approaching an asymptote, getting flat? It's rising. There's no asymptote. It's got to be rising. It's rising very slow, but it is rising. What about its x direction? It's going to infinity. Okay. Tell me about this other limit down here. Rising, falling, getting really flat.
But,
Flat, that means horizontal when I say that. What's happening this time? It's falling, negative infinity. So far, there's all of our infinities. You're going to have 3 infinities with exponentials and logarithms. You'll always have 3 infinities. You'll have one constant. It's got to be the x. What's the constant the x is approaching? -5. Now, are we approaching that from the left side or right side? Right. On the x values, if you're approaching a constant, we typically will have a plus or minus. Very few situations will you not see that. Questions over that? Good. I'm going to totally switch gears. So that was lesson 2.3 and 2.9 a whole bunch of times. I think 4 different times I showed you lesson either 2.3 or 2.9. Moving on to the next. Oh, can't move on yet. So let's see what you learned. Almost like a little quiz here. How will the end behavior of an exponential function always be described? I want you to think exponential, what it should look like. How will every limit be described on an exponential? What will be true of the x's? So if it's all reals, that means one's a negative infinity, one's a, what's going to be true of the y's? No, not for exponentials. So if your x's are all reals, so here's what will be true no matter what. You'll have one limit that's going to have a, say, negative infinity, and you'll have another limit that's going to have a positive infinity, because it's all reals. What will be true of the y's though? One is gonna be a constant,
One's gonna be this.
one's gonna be infinity. We don't know which one it is. So if the negative infinity has the constant, then the positive infinity would have a positive or negative infinity over there. It could be positive, it could be negative, depends on the problem. But what if this has the positive or negative infinity? Then in that case, this becomes the constant. So there's two situations. It's either constant, positive, or negative infinity, or it's positive, negative infinity, constant. But either way, you'll have negative infinity and positive infinity. Either way. Okay, so what's the relationship between an exponential and a logarithm?
We switch
I hear switch them. Switch what?
limits.
Switch the x's and
The y.
the y. So basically, I'm gonna write this all over again. Except this time, we're gonna do our slashes. On the x values, not on the y. So we'll have a limit. F of x equals, no matter what, this will be a negative infinity, and your other limit will be a positive infinity. No matter what, that's true. Because now the range is all reals. But what's going to change is your x could be the constant on this side. And if it's a constant on this side, then what's it going to be on over here? Positive or negative infinity, depending on the transformations. But what if it's not a constant? What if this side has the positive or negative infinity? Then what does it mean on this side? Then it's the constant. And again, you'll have a little plus or minus on your constant. Questions over that? Okay, I'm gonna skip a lot of what we did on lesson 2.4 and 2.5, and it's equal lessons 2.10. Those had to do with properties. I'm gonna save the properties till we come to solving problems. I'm gonna put those all together at the end where we just do inverses and solve together, okay?